This is section 6.2. We are dividing polynomials, so you might want to title your notes Dividing Polynomials. First of all, what is a polynomial? What did you say?
I said I don't know what poly means many.
That's right, poly does mean many. So nomial kind of sounds like number, sort of numeral.
Yeah,
Many numbers or many terms.
many terms.
We're going to divide a polynomial, many terms, by a monomial. What's a monomial? One term. So we're going to have multiple terms in the numerator, and the denominator we're dividing by a monomial will have one term. And that word monomial, mono means one. Nomial number, one number. One term. In this example, we have a polynomial in the numerator, and we have a monomial in the denominator. We're going to divide, and I think you'll like dividing a polynomial by a monomial. It's much better than dividing by a binomial. We're going to take each value in the numerator, and we're going to divide it by 5ab. So I'm going to write this out as 5a squared b divided by 5ab minus 15ab cubed divided by 5ab and 10a cubed b to the fourth divided by 5ab. You can think of this as three separate problems that you need to simplify, which we should be able to easily do. 5 divided by 5 is going to become 1. A squared divided by A is A, and B divided by B is going to cancel. So we have 1A or just A. Minus 15 divided by 5 is 3. A divided by A, those will cancel out, and B cubed divided by B, b to the second power. In our third term, we have 10 divided by 5. 10 divided by 5 is 2. A cubed divided by A, and b to the fourth divided by b. b to the third. Okay. We don't have any like terms. If we did, we would simplify here, but there are no like terms. This is my answer. What about this one? I'm going to write this out as 6x to the fourth, y to the third, divided by 3xy, and 12x cubed, y squared, divided by 3xy, minus 18x squared y, divided by 3xy. So let's go ahead and divide. In the first term, we have 6 divided by 3. 6 divided by 3 is 2. X to the fourth divided by x. X to the third power. Y cubed divided by y. Y to the second power. Plus 12 divided by 3 is 4. X cubed divided by x. X to the second. Y squared divided by y is y. And negative 18 divided by 3 in the last term. Negative 6. X squared divided by x. And y divided by y. We don't have any like terms here, so this is as far as we'll go. Any questions so far on dividing a polynomial by a monomial? I want you guys to try this next example on your own, and then we'll talk about it. When you simplified the first term, Michael, what did you get?
I got 1.
1, very good. When you simplified the second term, what did you get, JT?
2.
Anything else?
X cubed y.
X cubed y, good. When you simplified the last term, what did you get, Olivia? Minus 3x to the fifth. And then minus y to the second. Very good. I think that is correct. The correct answer here would be B. How many of you got B as your answer? Excellent. Okay, very good. Alright, so now we've talked about dividing a polynomial by a monomial. The next thing we're going to look at is what do we do if there's a binomial, if we're dividing by 2 terms. You see how this is different? I could write it out. But it's different. I cannot simplify it the same way that we've been doing because I've now got 2 terms in the denominator. In order to simplify this, we're going to have to use polynomial long division. This is new. However, you guys back in upper elementary, probably middle school, worked with long division. It's been a while, but you've used it. So before we even look at this problem, we're going to go back and practice a long division problem. Do you remember how to do long division? Maybe? Hopefully. I'm going to add a few more digits here. Because we need to be able to think about this. Okay. So to use long division, we want to know how many times 37 is going to go in to this big long number underneath the radical. Does 37 go into 9? No, 37 does not go into 9. Does 37 go into 96? Maybe not evenly, but how many times can it go into 96? If I take 37 times 2, it goes in there to 74. If I do 37 times 3, that's 111. So it'll go in there 2 times. I agree. So I'm using the number 96 here. So I'm going to put the 2, because it'll go in twice, I'm going to put 2 above the 6. What's that? You're close. We're going to tell things before we subtract. We need to multiply first. 2 times 37. What is 2 times 37? 74. And then we subtract. It's always subtraction there. So 96 minus 74 is 22. 37 should not go into 22. So what do we do with this next digit? Bring it down. So how many times does 37 go into 223? 6. Very good. 6 times. So I'm going to write 6 above the next digit. I'm just writing that right above the next digit. So 6. Now we multiply. 6 times 37 is?
222.
222. And we'll subtract. 223 minus 222 is 1. Now we'll bring down the next digit. Does 37 go into 14? No, so we have to do what? Bring down the next digit.
Yep.
So does 37 go into 146? Yes. How many times? 111. So 3 times 37 is 111. Then what do we do with 111? Subtract. So 146 minus 111, 135. Hold on, I think it'll go in there more than 3 times. Wait, you're right.
It's not 130.
Yeah, 30.
It's 1 minus 1 is 0.
Thank you, yes, thank you. Gonna say that's not gonna work out for us. 35 was correct. Bring down the next term. Does 37 go into 355?
Yes.
9 times.
99.
So 9 times 37,
333.
333. And subtract. So 355 minus 333 is 22. Do you remember what you guys used to do with that 22?
Remainder.
We would say R22, right? Bad news is we're not going to use R anymore. You cannot write R22. You guys are in high school, so we've got to do big kid things. When we have a remainder, what that means is we don't quite have enough of that 37 left to go in another time. So we're going to write that as a fraction, as 22 37ths. There's a fraction, 22 37ths. We're not really using numbers today. We're going to use polynomials and variables. We're dividing a polynomial by a binomial. So let's go back to this problem that we just looked at. We're going to use long division to simplify this. So we're dividing by x minus 5. That's going to go outside of my long division, outside of our division symbol. And x squared minus 2x minus 15 is going to go underneath that division symbol. Alright, so we're just going to go term by term like we did previously. X times what? X squared divided by x is x. I'm going to write it above this term because these are like terms. It'll help you in the long run. Trust me, I'll explain why here in a little bit. So I took x squared divided by x and I got x. I'm going to write it above my like term. So now we're going to multiply. I'm going to take x times both of these values. X times x is x squared. X times negative 5? Negative 5x. After we multiply, what do? Subtract. Now, here's the thing. You're not just going to subtract x squared. You're going to subtract the other term as well. So essentially, you're changing your signs. Multiplying by a negative 1 for subtracting. Tammy, you might want to write this down with us. So we distribute a negative. We're now subtracting. X squared minus x squared. Okay. We have negative 2x plus 5x, which is 3x. Bring down the next term. So, how many times does x go into 3x? We'll divide. 3x divided by x is 3x divided by x. In your mind, you think 3x divided by x is 3, right? It's a positive 3, so I'll put plus 3. So now multiply. 3 times x is 3x. And 3 times negative 5 is negative 15. What do we do after we multiply? Subtract. So really I'm changing both of my signs as I'm subtracting here. We have 0. We have a remainder of 0. So my answer is x plus 3. James.
Question.
Yes.
Will we ever have a remainder of something else?
Yes.
Okay, that's like for another day.
No, that's today. We'll get there.
Okay. Didn't know if that was just the other advanced thing that we were.
I want to make sure you got the regular prompt out first, then we'll add a remainder in. Okay?
Okay.
Okay, so I need to know how many times x goes into x squared. Well, what is x squared divided by x? X squared divided by x? Just x. So I'm going to write x above my like terms. Now multiply. X times x is x squared. X times 3, 3x. After we multiply, what do? Subtract. So we need to change both of the signs. We want these terms to cancel out every time. If they don't, you did something wrong. They should cancel out every time. 5x plus a negative 3x, or 5x minus 3x is 2x. Bring down the next term. So how many times does x go into 2x? 2 times. It's a positive 2, so I'll say plus 2. Now distribute. 2 times x is 2x, and 2 times 3 is 6. After we multiply, what do? Subtract. We'll change both of those signs. Remember, we want those first terms to cancel out. You want to multiply by something so it's the same number, and when you change that sign, they're going to cancel out.
And also preferably you want the other ones to cancel out too.
Yeah, it
But
works
it doesn't
out.
always work.
Right, doesn't always work that. Molly,
How did you get to negative 3x?
here. Back up here, I had x. You okay for the x came from? When I took x times x, I got x squared. X times 3, I got 3x. After we multiply, we subtract. We're really subtracting that whole expression. So we're
Yeah, so you
essentially
just
going to
grab the
distribute a
negative
negative 1. That's where it came down as a negative 3x. That's our answer. Circle with A. So like I said, these previous two have been nice and they've had no remainders. Let's look at one where we do have a remainder. Now this problem's written a little bit different than the others, but it's saying the same thing. If we have a negative exponent, what does that really need? What do we need to do with that? Change force. Doesn't that mean that's really a squared minus 5a plus 3 divided by 2 minus a? Okay. And I don't like how that's written as 2 minus a. We need to change that around. Not a minus 2, but you could say negative a minus 2.
Wait, wouldn't it be negative a with a plus
Right, I apologize. I said it wrong. You're right. Negative a plus 2 is actually correct. Let's just flip that around. So now we can do our long division. So how many times does negative a go into a squared? We'll just divide them if you're not sure. A squared divided by negative a is? Negative, what's a squared divided by a? A, just negative a. So I'm writing those above my like terms. The reason I do that and write above my like terms is so that the next number I'm going to put here, it's going to have to be a constant. It'll just help to reinforce that you've got the right numbers in the right positions. So now multiply negative a times negative a, positive a squared. Negative a times 2 is negative 2a. What do we do next? Subtract, so really we're changing those signs. Remember, we want those first terms there to cancel out every time. We have negative 5a plus 2a, negative 3a, bring down the next term, plus 3. So how many times does negative a go into negative 3a? Not negative 3, so we have negative 3a divided by negative a Just 3.
3.
Positive 3, so we'll put plus 3. So 3 times negative a is negative 3a. 3 times 2 is 6. So now change your signs. Once again, we want those first terms to cancel out. 3 plus negative 6 is negative 3. So now we have a remainder. We're not going to say r negative 3. Negative a plus 2. I'll write this a little bit bigger. It's negative a plus 3 with the remainder of negative 3 over negative a plus 2.
Oh, okay. So they also put it differently on top of
What's that?
they put it differently on the problems as well.
I put it different?
They still switched them around on that.
Right here?
Yeah, where it was.
Yep, we could leave that as 2 minus a if we wanted to. That's fine. So, D? Is D right? Okay, we need to do one where we're missing a term. Sometimes that'll happen. Let me see. Okay, how about this one? In this problem that we're missing a term. Does anybody see or know what I mean when I say missing a term? Yeah, we're missing that regular k to the first power. Do you see that? We have k cubed, we have k squared, but we're missing that k to the first power in there. You have to have every term in there. If you're missing a term, we've got to add it in. So when we add it in, this is what it's going to look like. We're going to add it in as 0k.
Okay.
Yeah. It's like okay, doesn't it? Add in that 0k. Anytime you're missing a term, you have to account for it. It has to be there. Otherwise, your polynomial long division won't work. So let's go ahead and set up our division. We have 5k cubed plus k squared plus 0k minus 7. I'm going to let you guys start it and see if you can do it. We're going to go through it together in just a second, but I know some of you like to think about some of this on your own. Try it and we'll talk about it. Okay, so 5k cubed divided by k is
5k squared.
5k squared. Now it's a k squared, so write it above your like term. 5k squared. These guys are like terms. Do you see that? They're both k squareds.
Yep.
Write them above your like terms. It will help you to stay organized. Now multiply. 5k squared times k.
5k cubed.
5k cubed. 5k squared times 7. 35k squared. After we multiply, what do? Subtract or change your signs. Both of the signs. Remember, you want these to cancel out. That should happen every time. We have k squared minus 5k squared minus 35k squared. Negative 34k squared. Bring down the next term. How many times does k go into negative 34k squared? Just divide. Negative 34k squared divided by k.
34.
If you're having trouble thinking about it, just write it out. What is negative 34k squared divided by k? Negative 34k. Now, has a k, so I'm going to write it above its like term, right here, negative 34k. Now distribute negative 34k times k, negative 34k squared. Negative 34k times 7, negative, it's a big number, 238k. After you multiply, what do? Change your signs. Both of those can become positive. Remember, you want that first term to cancel out. It should happen every time. 0k plus 238k. 238k. Bring down the next term. So how many times does k go into 238k? 238 times. Again, what I'm doing is I'm taking 238k, dividing by k, dividing by this number here, that term. It's 238. So 238 times k, 238k, 238 times 7, after you multiply, what do? You've got to change your signs. So once again, those should cancel out. We have negative 7 minus 1,666. That's our remainder. How are we going to write our remainder? Good job, Matt. I'm just going to rewrite it down here. So we have 5k squared minus 34k plus 238 minus 8 plus 7. The more you practice these, the better you're going to get at them, just like anything. What's that? Alright, so today we're practicing log division and dividing a polynomial by a monomial. Tomorrow we'll do some more work with polynomial log division, but you need to come ready to work tomorrow. Today's assignment is going to be out of the book. Okay, hang on just a second, guys. I need to change this assignment a little bit. We're going to do 1 through 5, 12 through 17, not 123 through 17, 12 through 17, and 20 through 22.